Welcome to day 10, 4.4, models using function notation. All right, so we're going to walk through a model problem with function notation, and after that you should be pretty comfortable with all of these. So, a rematch of the fabled race problem. Coming off an embarrassing loss to the tortoise, the hare wanted a rematch. The tortoise, being a wise old animal, agreed to race again if he was given a 30-minute lead. Both started at the same point. The tortoise races at a constant speed of 50 feet per minute, and the hare races at a constant speed of 160 feet per minute. We're going to let x be the number of minutes since the tortoise started. T of x is the number of feet the tortoise has gone, and h of x is the number of feet the hare has gone. Okay, so our first goal is to write the particular equations expressing t of x in terms of x and h of x in terms of x. All right, so let's get down to it. We are given the fact that the tortoise gets a 30-minute lead, right? We're also told that the tortoise races at a constant speed of 50 feet per minute. That's like our slope for the tortoise. So then what about the hare? Well, the hare, we are told, races at a speed of 160 feet per minute. We can think of that as the slope for the hare. Okay, let's write our equations. So we're going to write the equation expressing t of x in terms of x. So our tortoise equation, what's that going to be? Well, let's think of some ordered pairs, right? So the tortoise begins the race. He starts at the point 0, 0. Okay, so we can kind of think of it that way. The hare, he starts 30 minutes after the tortoise does. So remember, x is the number of minutes since the tortoise started. So the hare starts 30 minutes after, and they both start at the same place, so he's going to be at 0. So this should help us think about our equations. So our tortoise, in terms of x, hopefully you recognize our tortoise. We have our slope of 50 feet per minute, and then we have x, which represents the number of minutes since the tortoise started. So we're going to have 50x. For the hare, we have to keep in mind that he starts 30 minutes after. So I want you to try to come up with the equation for the hare on your own, and we'll compare. Hopefully you had a chance to think about it. So our hare equation, h of x, in terms of x, is going to be our slope, 160, times our point, right? Which is just going to be x minus 30 if we're thinking of point slope form. So here are two equations that represent our tortoise in green and our hare in blue. I want you to go ahead and complete part B on your own. So find t of 35 and h of 35 and answer the question, who is ahead at the end of 35 minutes? Pause the video and check back. I got t of 35 to be 1,750 feet and h of 35 to be 800 feet. Now we have to answer the question, who is ahead at the end of 35 minutes? Hopefully you recognize that the tortoise is winning. So we will answer the tortoise is ahead. Go tortoise. All right, so now let's take a look at the next question. The next question asks, when will the hare catch up with the tortoise? How far from the starting point? What do you think we need to do here? When will the hare catch up with the tortoise? Hopefully you recognize this means we need to set those two equations equal. So t of x has to equal h of x. So we'll go ahead and set those two equations and solve. So t of x is 50x. And h of x we know is 160 times x minus 30. I want you to pause the video right now and solve for x. That will help us answer when will the hare catch up with the tortoise. Then we'll talk about how far from the starting point that is. Okay, so after setting these two equations equal to each other, now we go through and solve. And I got x to be about 43.6 minutes. So when will the hare catch up? We answer the question. The hare catches up after about 43.6 minutes. Now we have to answer how far from the starting point is that? So what are we going to do? Well, what we can do is we can simply plug this x value in to either one of the equations. Now I will choose the tortoise equation just because it's a little easier to figure that out. It doesn't really matter because at this point they're both equal. So go ahead and let's set that up. I know we're going to solve for when t of 43.6 is equal to h of 43.6. Okay, those are the same, right? So all we need to do is go ahead and plug in. So that's going to equal 50 times 43.6, which is at 2,180 feet. So how far from the starting point? 2,180 feet is where they both are. Let's look at part D. Before starting, the two animals agreed that the race would be 2,000 feet. Who won? By how many feet? Well, based on our answer from part C, we should know who won. Why? Because we know when they meet. They meet at 2,180 feet, correct? So who won? Hopefully you recognize that the tortoise still won. But let's just make sure we understand why. And let's talk about by how many feet. So what can we do? Well, to start off, we can find out when the tortoise got to 2,000 feet. So we're going to set our tortoise equation equal to 2,000. Okay? So we get 50x equals 2,000. So we get x to be 40. So that's how long it took the tortoise to finish the race. Okay? But how many feet did he beat the hare by? So what we can do is we can now find h of 40 to figure out where is the hare at this point. How far behind is he? So if we find h of 40, so that's 160 times 40 minus 30, we will get 1,600. Okay? So the hare is at 1,600 feet from the starting line after 40 minutes, which is when the tortoise finished the race. So who won? We can go ahead and say the tortoise won. Way to go. By how many feet? Well, the tortoise finished at 2,000 feet and the hare was only at 1,600 feet. So the tortoise won by 400 feet. The last thing we're going to do is we're going to graph both of these equations on the same set of axes. Use dotted lines for the graphs in parts of the domain where the equations do not apply. Make sure to label everything, set up a good, or label your axes appropriately, scale your axes appropriately. Go ahead and graph this and then come back and let's compare what we get. Here's what my graph looks like. Make note that I labeled my axes, the number of minutes since the tortoise starts, and the number of feet traveled for my y-axis. I scaled my axes accordingly so I can use up a good portion of my grid. All right, and same with my y's. I went up every other by 300, okay? And then we go ahead and we include the key pieces. Well, the tortoise starts at 0, 0, and he ends the race at 40 minutes, 1,600 feet. At 40 minutes, 2,000 feet. At 40 minutes, the hare is only at 1,600 feet. So I drew that line and noticed how up until the finish line, I have solid lines on both of these, and everything else beyond that is dashed. Also, I noted where they meet. That's what this black dot represents, is where the two actually meet, but the race is already over at that point. You should also make sure that you include your lines. So T of X is labeled, and so is H of X. If you have questions on any of this, make sure to ask in class next time we see each other.